c cubed, and the whole thing squared. And this whole thing, okay, must be equal to 50 times 10 to the power 3. Okay, so now we are going to solve for C. Okay, we have to find C, right? So before you can solve for C, you have to like manipulate the equation a bit. Okay, so I'm going to have a common denominator, okay, for the square root term to make our calculation easier later on. So minus 2500 C minus by 7223 over 2 pi C cubed, and then squared, plus by, I'm going to multiply by 2 and divide by 2 also. So 110,400, right, divide by 2 pi C cubed, and this thing is squared. So this is 50 times 10 to the power 3. Okay. So what I'm going to do now is I'm going to square both sides. Okay, so we'll get minus 2500 C minus 72,123 divided by 2 pi C cubed squared plus by 110,400 over 2 pi C cubed. And I'm going to square, so for 50 power 3 squared is equal to 2.5 times 10 to the power 9. Let me do it again. So 50 power 3. Yep. Okay. Then I'm going to take out the common denominator. So 1 over 4 pi squared C6. Right. Then this will be minus 2500 C minus 72,000 squared plus by 110,400 squared. So this is equal to 2.5 times 10 to the power 9. Okay. So tidy things up a bit. So this is equal to minus 2500 C minus by 72,123 squared plus by 110,400 squared. This will be equal to 2.5 power 9 times 4, 10 times 10 to the power 9 pi squared C6. Okay. And then when we expand the term, you get 6.25 times 10 to the power 6 C squared plus 360 times 10 to the power 6 C plus 5.184 times 10 to the power 9, and then plus by 12.18816 times 10 to the power 9, and then this is 10 times 10 to the power 9 pi squared C6. Okay, so we are almost there. So the equation that we're going to solve, right, and then minus 6.25 times 10 to the power 6 minus by 360 times 10 to the power 6C minus by 5.184 power 9 plus by 12, 5.184 power 17.372 16 times 10 to the power 9. The whole thing is equal to 0. Okay. So you can simplify it further. 10 times 10 to the power 3 pi squared C6 minus 6.25 over here. I miss out a C squared. Okay, minus by 360 C minus 17.37216 times 10 to the power 3. The whole thing is equal to 0. Okay, so you can solve for this using your calculator. So what I've done, okay, I will not show you how to do it on the calculator here, but if you go to Avenue to Learn, let me go into Avenue to Learn. Yeah, as you can see, this is Avenue to Learn. If you go to Content and you go to week 13, right, I have uploaded solving higher order polynomial equation using FX991. So I want you to watch that video. It's just a 3 minutes video on how to solve it. Okay. So when you solve it, you get C. Okay, the output from the computer, not computer, calculator, BC is equal to minus 0.7466 inch. Okay. Now, in the test, I only allow you to use calculator. Okay. Then whatever the calculator says, okay, I will accept it. But in real life, this has to be a positive value. Okay. You cannot use the calculator. You need a computer. Okay. But there's no computer in your exam room. So I allow you to use the negative value. So you're going to use C is equal to 0. You make it into an absolute value, 0.7466 inch. Okay. So therefore, the diameter is equal to 2C. So it's equal to twice 0.7466. Okay. So 2 times by 0.7466 is equal to 1.4932 inches. So we are not done yet, okay? We have to determine, we have to ensure that the stress max and stress mean is less than what? Or the absolute value for stress max, the absolute value of stress mean must be less than what? 100 megapascal. Okay, so how do we do that? Okay, so we know that our stress average, the formula is equal to what? Minus 2500C minus by 72,123 divided by 2 pi C cube. Right. So we're going to take the value, right? So this is equal to minus 2500 multiplied by 0.7466 minus by 7200, and then we're going to divide by 2 multiplied by pi multiplied by 0.7466 cube. Okay, so this will be equal to minus 2500 times by 0.7466 minus by 72,123 divided by 2 divided by shift pi divided by 0.7.66 power 3 is equal to minus 28.249. Okay, so we know that this is minus 28.249 times by 10 to the power 3 psi. So stress max is equal to minus 28.249 times 10 to the power 3 plus by 50 times 10 to the power 3, which is the radius, plus by 50 to the power 3. So this is 21.751 times 10 to the power 3 psi. And this is less than what? 100 times 10 to the power 3 psi. Right? And then the stress mean is equal to minus 28.249 times 10 to the power 3 minus by 50 times 10 to the power 3. So 28.249 plus 50 is equal to 78, negative 78.249 times 10 to the power 3 psi, which is greater than minus 100 times 10 to the power 3 psi. So both are what? Both are okay. So this design, so what this means is, okay, this design that we've done, right, is exactly what we've drawn, okay? The stress minimum over here and the stress maximum, we found that they are inside the what? Inside the box, okay? So this is how, so what you've seen down here is true engineering work on how to design a shaft based on the applied load and using a criteria, okay? So this is true engineering work, okay? So we have to determine where failure will occur first, okay? We have to understand what is Tresca criteria, sketch the element, and then determine which formula to use for Tresca. Remember, Tresca is 2, which is tau max is equal to stress U divided by 2, or it can be tau max experimental is equal, or tau max is equal to half of bracket of stress max minus stress mean, okay, by looking at the circle, okay. Then from here, it's just algebra from here, I think. Okay, you have to be really careful with the math down here. And then most important thing is you have to do the checking, okay. If doing the check, if your maximum stress is outside, then you have to increase the size of the shaft, okay. Okay, that's all for today, and I'll still stay behind if you have any other question.